The mathematics Strand project that I did is centered around the 8th grade Virginia SOL 8.9 on the Pythagorean theorem. SOL 8.9 states that the student will A. verify the Pythagorean theorem, and B. apply the Pythagorean theorem. The activities in this project are designed to help students understand and verify the Pythagorean theorem when working with right triangles. The use of visuals will help students to better understand the theorem, and a lesson is integrated with history to help students better understand the contributions that Pythagoras made to the modern world. Students will practice making right triangles and applying the Pythagorean theorem to them. This project provides a number of activities, a graphic organizer for taking notes, and assessments that will support the student learning of the Pythagorean theorem. Some of the essential questions that we will cover in this unit are: how is the Pythagorean theorem relevant today? And what are some ways that it's used in society today? And how can the Pythagorean theorem help you find the distance on a coordinate plane? Some of the materials that will be needed: of course, you want to use your smartboard in the classroom, individual Chromebooks for the students. You'll need large graph post-it paper for one of the activities. You'll need regular graph paper for the other activities. Cheez-Its, 2 to 3 boxes of them. You'll need some straws that are cut in various sizes, tangrams, pencils, and colored pencils. For the history activity, the student will apply social science skills to understand ancient Greece in the terms of its impact on Western civilization by citing and explaining contributions in drama, poetry, history, sculpture, architecture, science, mathematics, and philosophy, with emphasis on Socrates, Plato, and Aristotle. For our purposes, though, our students are also going to include Pythagoras. And what they will be doing, since they were in 8th grade, they should be able to easily make some Google slides, and they will use at least 5 slides about one of the main characters in ancient Greece. As we are doing Pythagoras, some of them will choose him. They will create slides to identify their person of interest, discuss his life, his accomplishments, and how his contributions are still being used in today's world. They will go on the internet to find the information needed for their slides. They will include a picture of the person or a likeness of him, if possible, and they will present their slides to the class, and they may work with a partner on this activity. For the math tiered activities, Group 1, grade level, below grade level, I will have them complete a fun hands-on activity where they use square cheese crackers to demonstrate the Pythagorean theorem. The students will be given a half sheet of large graph paper and some Cheez-Its, crackers, and some colored pencils. They will begin by drawing and labeling the parts of a right triangle. The Cheez-Its will be used to create squares from leg A and B. Leg A will be 4 Cheez-Its with an area of 16 Cheez-Its, and leg B will be 3 Cheez-Its with an area of 9 Cheez-Its. The square from the hypotenuse will not be filled in with Cheez-Its at this time. What I want the students to do is I'm going to ask them how many Cheez-Its they think will be needed to cover the area of the square created from the hypotenuse C. After they guess, the students will be instructed to move their Cheez-Its from legs A and B into the square for the hypotenuse. And right now I just have a sample of where they created their right triangle, and then from there we will move on to forming the square over here, and then they will take these and fill them in over here on that square. And this will help them to realize that the area of A plus the area of B will equal the area of C. Students will be asked to describe this relationship in their own words. And if there's time and if they have enough Cheez-Its, they can practice and try to come up with their own. And that can be turned in for a formative assessment if the teacher so desires. Students may enjoy their snack when they finish with the activity. For Group 2 on grade level, students who are on grade level, the teacher will have them use tangrams to form right triangles on regular graph paper. And for that one, I have this designed. Again, this will illustrate the Pythagorean theorem because they will have to piece together different triangles to form the squares. They will trace their shapes and shade them in with colored pencils. They'll label them. They'll write the Pythagorean theorem out and fill in for it and solve it. And this activity will help provide them with a visual. Group 3, my above grade level students, will be given straws of different sizes. And I just took straws and cut them into pieces, and they are not allowed to make any cuts or bends in their straws, but they can take their straws and they will try to make a right triangle out of them. And because not all the straws will make a right triangle, they are more than welcome to share with their partners or within their small groups and trade straws, or they may piece together straws to get what they need. And they'll be encouraged to try different measurements on their own. They again will label everything and use the formula and work it out to show that they understand the Pythagorean theorem. For the assessments, for my formative assessment, for my first formative assessment, I will review perfect squares and square roots, and we'll go to IXL on their Chromebooks, and there is a game called Concentration, and it's a short review game that we can use. The goal for students to meet on this is an 80% accuracy. It can be played individually or as a class using the smartboard. The second formative assessment I will use is another activity that is a great visual that allows me to see who gets it and who doesn't. I will give each student a card with 3 measures on it, and the student will use his graph paper to graph a right triangle. They will again label the legs and the hypotenuse, and they will draw the square for the hypotenuse and record the measures of each one on the graph. And then I can see how well they understand it. They will use their colored pencils and a ruler to ensure that they have straight lines. For the summative assessment, I will have students participate in a scavenger hunt involving the application of the Pythagorean theorem. They will each receive a sheet for them to show their work, and they will work with a partner. They will solve real-life problems using the Pythagorean theorem as they work to save the princess in a Mario game. Each student will choose a place in the room to begin their hunt. I'll have posters scattered all around the room. And they will start at their poster. They'll solve the problem, and they'll search the other posters to find their answer, which is boxed on the bottom. And an example of that is this right here. And they will use that to find their answer. And once they find their answer, then that poster is the next clue that they solve. And they will do that until they've completed the whole round. And that's my mathematics Strand project. Thank you. Have a good evening.